thing in the universe. What, besides Darth Vader and a lightsaber? Well, actually, I was asking about black holes, swallowing anything that comes too close without doubts or regrets. Blinding supernovae, mysterious hypothetical wormholes. Yeah, probably not. Because the most terrifying things in the universe are likely to be rogue planets. Ooh. Nomads, orphans, sunless, unbound. That is what these creepy worlds are called. They have no sun. Unwanted in their star systems, they were once ejected into the soulless emptiness of space. And some of them didn't even have their own star systems. They were born lonely. Rogue planets don't have sunlight. The never-ending night reigns on their surfaces. No light means no warmth, and almost no chance of any kind of life to be able to survive in these frozen worlds. How lonely! Kinda makes you tear up a little. Okay, I'm done. But how do rogue planets get born? When planetary systems, including our solar system, form, it can get messy. Most planets appear from the cosmic dust that is floating in space around a newborn star. And when these planets form, they push one another. This gravitational game of tag often shoves some planets toward the edges of the newly formed star system. And sometimes, one or two of them get ejected from their home altogether. There are also nearby stars that can play with planets too. Stars aren't often born on their own. Clusters of dozens to thousands of stars can appear in space. And in such a crowded environment, it's not a rare occurrence when a star with its own planets steals away a planet or two from another star. After getting a new planet, it can keep it for itself or throw it away into the dark, deep cosmos. Some free-floating planets pop up in a different way, with no parent star to help them. Like stars, they form from collapsed clouds of gas and dust. But since they are too weak, they can't put on enough weight and can't start nuclear reactions that make stars emit light. Such planet-like objects are known as failed stars. Or planets can go rogue after their parent stars disappear. Yes, sometimes stars go out, destroying some of their planets in the process. At the same time, the most distant ones, located in a safer zone, are left more or less intact. But the enormous force of a supernova ejects these planets away from the former star at a tremendous velocity. In any case, astronomers think there may be more rogue planets in our home Milky Way galaxy than anyone ever suspected. A recent simulation has shown there might be billions of them. But the problem is rogue planets are very hard to detect. You know, it's a tricky feat to find any exoplanet, even when it belongs to a planetary system. After all, planets don't give off their own light like stars. That's why when astronomers want to locate an exoplanet, they look for something blocking the light of its parent star, and it's usually the very planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because there's no parent star and thus there's no light to get dimmer. Another method of detecting exoplanets is the radial velocity method. It detects the planet's gravitational effect on its parent star. But, as you may guess, it doesn't work with rogue planets either. Luckily, there are still some ways we can detect these space wanderers. Imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the light of the star. This makes it appear brighter than usual. The trickiest part is to figure out whether this object is a rogue planet. It's true that the stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there might still be a small parent star invisible because of the glare of the main star. And astronomers have to wait for a long time, sometimes up to a decade, for the main star to move a bit. Then they can finally check if there's also a parent star out there. If there's no parent star in sight, then it's proven the planet is traveling solo. Not apparently. So far, astronomers have identified at least 70 rogue planets or candidate rogue planets. At the same time, we know about more than 5,000 exoplanets in planetary systems. That's a huge gap that proves that detecting rogue planets is a tricky business. Interestingly, free-floating planets might not be as lonesome as we think. They can potentially have moons of their own. They might even take them along when they get pushed out of their cosmic homes. But could a free-roaming world, and possibly its moons, find a new home near a different star? Some experts think it's unlikely. The universe is a very spacious place, and even a large star with an incredible gravitational pull is hardly able to catch a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or even slowing down. Now let's have a look at a rogue planet we have managed to spot. Just 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way galaxy. And even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field, 4 million times stronger than that of our Earth. The exoplanet, with this crazy long name, also produces amazing auroras. When it was discovered a few years ago, astronomers were almost sure they had detected a brown dwarf. This is an object too large to be a planet and too small to be a star. But later, scientists got some evidence that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce such auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. To find more amazing rogue planets, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey using the powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept called Cleopatra, the clever NASA acronym for the Contemporaneous Lensing Parallax and Autonomous Transient Assay. See, I told you it was clever. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. Could Earth one day turn into a frozen sphere aimlessly floating through space? Unlikely. Since our sun isn't going to blow up one day, our world isn't likely to be pushed out of the solar system by our star going supernova. But a rogue planet could cause life on Earth to end. Oh boy. One day, such a space intruder might push Earth out of the habitable zone near the Sun and take its place. And our planet would have to retreat to an extreme orbit farther from the Sun. The climate all over the planet would start getting colder and colder, turning first half of the planet, then our entire world into an icy desert. There would be a lack of food and other resources. It'd be getting darker and darker. There wouldn't be enough light for planets to get energy. They would wither, and animals that used to feed on them wouldn't be able to find food. Most species would go extinct. The farther our planet would be from the Sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Wow, bummer. But hey, don't worry, I guarantee that will never happen. At least, not on my watch. Back in 2008, astronomers found a mysterious something orbiting a star called Fomalhaut. This star is very bright and sits about 25 light-years away from us. Trillions of miles, sure, but pretty close in space terms. It's in the constellation Southern Fish, the one that looks like a single fish floating in the southern night sky. It's a small and relatively dim constellation, but Fomalhaut is what makes it so special. In Arabic, this means mouth of the fish, and you might guess where that name comes from. It's the brightest star in the constellation. If you're in the southern hemisphere, you can easily spot Fomalhaut with the naked eye. For people in the northern hemisphere, it's visible in the fall, low on the southern horizon. But this constellation has a beautiful story. The myth says that this fish is the one that saved the deity Dursida, who had fallen into a lake. so it became the symbol of rescue and protection. The fish in Pisces is said to be the offspring of the southern fish, forming a kind of family. At the same time, Fomalhaut is sometimes called the lonely star because it's one of the brightest stars in its part of the sky, but it doesn't have many bright neighbors. Hey, I can relate to that. Nah, just kidding. Fomalhaut is also a young star. It's only about 440 million years old. Now that sounds like a lot, but our Sun, in comparison, is 4.6 billion years old. And finally, it's surrounded by a giant ring of dust and gas. This is called a debris disk. It's like a dust cloud that serves as the birthplace of planets. It's like the Kuiper Belt in our own solar system, where Pluto lives, but on a much grander scale. But then, astronomers noticed something odd about this disk. It wasn't evenly shaped. This means that there's something that influences gravity nearby. A planet, perhaps? And when they took pictures of the disk, they found a faint glowing dot inside it. That was our mysterious gravity center, Fomalhaut b, or how they named it later, Dagon. They immediately thought it was a planet. In 2008, it was a huge deal because scientists captured an actual image of it using the Hubble Space Telescope. Now that's a super rare thing, especially for objects outside our solar system, not to mention such tiny things as planets. And the photos were fascinating. At first, everyone was excited about the new world. Scientists thought that Dagon was a massive planet, something maybe like Jupiter, a gas giant. They even guessed that it had an oval-shaped orbit, which means that it would take about 1,700 years to go around its star just once. It's one of the craziest orbits we've ever seen. But as they kept studying Dagon, they noticed that things don't add up. For starters, they couldn't find it in infrared light. Now, planets that big usually give off heat, and telescopes like Spitzer, which look for heat signals, found nothing. Weird, right? Also, the planet was moving too strangely. Its orbit didn't match what you'd expect if it were shaping the dust ring. So scientists started thinking, maybe it's not a planet at all. And as the doubts creeped in, the hype calmed down. In 2020, they noticed another strange thing about Dagon. It was getting dimmer and spreading out. And well, planets don't usually do that, but clouds of dust do. This led to a new idea. What if Dagon isn't a planet, but the result of a massive collision? Imagine two big chunks of ice or rock smashing into each other at incredible speeds. That's what they think happened here, a giant space crash that led to lots of debris. That's how it got officially removed from the list of exoplanets. But then, in 2023, the new James Webb Space Telescope, which is even more powerful than Hubble, decided to take a closer look at Dagon. And when scientists looked at the data, they jumped back into the previous debates. Wait, it might be the planet after all. All this scientific back and forth led to Dagon getting dubbed the zombie planet. But after a while, astronomers finally found the middle ground. Dagon really turned out to be a dust cloud that's slowly disappearing, but there could still be hidden planets in the system. There's another ring of dust closer to the star that might be shaped by an unseen planet. There are many mysterious weird planets out there. Trace 2b orbits a star 750 light-years away from Earth, much farther out than our Dagon. It's in a region of the sky that's been heavily studied by planet hunters. It was first discovered in 2006 by the Transatlantic Exoplanet Survey, an observatory with a bunch of cool telescopes that are used to find planets. They use a witty method for it. They observe the stars, and when they see unexpected dips in brightness, that means that something must be passing in front of the star, making it a wee bit darker. This is called the transit method of the planet discovery. When Trace 2b was spotted that way, scientists took a closer look and confirmed it. It had a certain gravity pull that caused its star to wobble. But that also means that the planet should be gigantic, probably a gas giant like Jupiter or Saturn. But, unlike Jupiter, Trace 2b is much closer to its star. This makes it a special type of a planet called hot Jupiter. That's what we call gas giants that orbit so close to their stars that their atmospheres are scorched to extreme temperatures. Imagine if Jupiter was not only horrifyingly massive, but also almost burning. This planet is tidally locked to its star. This means that it always faces the sun with one side, just like we can only see one side of our moon. Its day side is blisteringly hot, but even the cooler night side has temperatures around 2,900 degrees Fahrenheit. But there was something very eerie about this new world. What really made it stand out was its albedo, a measure of how much light the planet reflects. Most planets, like Jupiter or even Earth, reflect a good amount of light thanks to clouds, ice, and other stuff. This is what allows us to see those planets after all. But TRACE 2b is almost completely black. For some reason, it reflects less than 1% of the light that hits it. It's darker than coal or fresh asphalt. So, why is that? After some thought, astronomers think it might be because of its atmosphere. Jupiter has bright reflective clouds of a gas called ammonia, but TRACE 2b probably doesn't have those. Since it's so close to its star, they'd burn up and get stripped away. So, its atmosphere might be made up of chemicals like sodium, potassium, or titanium oxide. All of this stuff absorbs a lot of light, and if you look directly at that planet, you'd see it almost as a black hole. What's even more horrifying is that if you were floating in it, since it doesn't have a solid surface, these elements could make the sky above look like an endless void, even if it's daytime. Though you'd probably still see its star, even it would be completely surrounded by blackness, like light at the end of a tunnel. In that case, shouldn't it be completely invisible? Well, it kind of is. But it also emits a faint red glow, likely due to its scorching high temperature. And even though scientists have studied TRACE 2b for years, some questions remain unanswered. Why is it the darkest planet we've ever found? Is it possible that there are some unknown chemicals in its atmosphere? What hides beneath the darkness? These Jupiter-like planets are often crazy, like WASP 76b, for example. This is another gas giant located about 640 light-years away, this time in the constellation Pisces. Just like TRACE 2b, this exoplanet is tidally locked. One side has a temperature of over 4,000 degrees Fahrenheit, while the other side remains in constant darkness. But what's crazy about it is that the extreme heat on the day side vaporizes metals like iron. The planet has insanely strong winds, and they blow this molten iron to the colder side. And you guessed it, the iron gets solid under colder temperatures, and we end up with a horrifying iron rain. All this stuff sounds like science fiction, but it's real, waiting to be explored.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye. unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered two other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
Mercury gets a bad rap for always being hot, but that's not entirely true. The planet's got no atmosphere, so its temperature swings are wild. When it's facing the sun, it can get up to a blistering 800 degrees Fahrenheit, but when it's turned away, it drops to a frigid minus 290 degrees. The reason for this is that Earth has a cozy atmosphere that keeps our temps in check. Mercury doesn't have that luxury, so it's at the mercy of the sun's rays. But despite all that, Mercury's still worth checking out. It's close to the sun, which makes it a prime spot for studying how solar radiation affects planets. And even though it's not exactly hospitable to life, there are still plenty of mysteries to unravel. Venus is often referred to as the sister planet of Earth. Yeah, many people believe that it's this beautiful and lush planet, just like our home. But boy, are they wrong. In reality, Venus is a total diva. She's got this thick atmosphere that traps heat and causes surface temperatures to reach up to a scorching 864 degrees Fahrenheit. I mean, I get it. Venus wants to stand out and be unique, but she's taken it to a whole new level. She's like that one friend who always has to one-up everyone else. Oh, you think Earth is cool? Well, I'm the only planet that spins clockwise. Beat that. But let's be real here. Venus is just trying too hard. She's got these crazy sulfuric acid clouds that rain down on her surface and make it impossible for anything to survive. It's like she's trying to keep all the attention for herself by making sure no other life forms can exist. And her atmosphere, it's so thick and heavy that it would crush us like a grape. So, yeah, Venus may look pretty from afar with her bright, yellowish glow, but don't fall for that. She's a total drama queen who just can't handle sharing the spotlight with anyone else. Anyway, enough about Venus. Let's focus on the real star of the show, Earth. We may not have all the flashy features that Venus has, but at least we're hospitable and welcoming to all forms of life. Plus, we've got pizza. So who needs sulfuric acid clouds anyway? You may think that since we live on this planet, we know it from A to Z, and there is no room for any misconception. Alrighty, then tell me, what shape is Earth? If you say it's round, sorry, but you're not right. So, our planet may look like a ball, but it isn't a perfect one. You see, because of the spinning action, the north and south poles get squished a bit and they're sort of flat. The Earth's wobbling, and other stuff are actually causing it to change shape over time, but it's still roundish. Let's talk about Mars, the red planet that has fascinated humans for centuries. Now, I know we all have this idea that Mars is this habitable planet that we can just pack our bags and move to if Earth becomes uninhabitable. Nope, that's not entirely true. One common misconception about Mars is that it has a breathable atmosphere. While Mars does have an atmosphere, it is much thinner than Earth's and consists mostly of carbon dioxide, making it unsuitable for human life without extensive life support systems. So if you're planning on taking a stroll on the surface of Mars, you better pack your oxygen tanks. But hey, that doesn't mean we should give up on our dreams of colonizing Mars. Who knows? Maybe in a few decades, we'll be able to call Mars our second home. Some people think Jupiter is a solid planet, but let me tell you, that's just a bunch of hot air. Literally. Jupiter is actually a gas giant made up mostly of hydrogen and helium. It's so massive that it doesn't even have a solid surface. I mean, I thought my bed was soft, but floating on a cloud of gas sounds pretty comfy too. Jupiter's atmosphere gradually transitions into its interior, which means it's like a never-ending party in there. Saturn's rings are one of the most fascinating features of the planet. So, a common misconception about Saturn is that its rings are solid. In reality, Saturn's rings are made up of countless small particles of ice and rock that orbit the planet. They stretch out over 174,000 miles from the planet's surface, but are only about 65 feet thick. The particles that make up the rings range in size from tiny specks of dust to large boulders. Scientists believe that the rings were formed from debris left over after the formation of Saturn and its moons. Over time, the particles were pulled in by Saturn's gravity and formed into the beautiful rings we see today. Saturn's rings also have some amazing features, such as gaps and divisions caused by the gravitational pull of nearby moons. There are also waves and spiral patterns that are created by the gravitational interactions between the particles in the rings. Despite their beauty, Saturn's rings are constantly changing. The particles collide with each other, creating new ones and breaking apart others. This means that the rings we see today may look very different in the future. So next time you look up at Saturn and its rings, remember that you're looking at a cosmic snow globe made up of billions of tiny particles floating around the planet. Now, one common misconception about Uranus is that it's a lazy dude who can't even rotate properly. People think it just rolls around on its side all day long, but let me tell you, that's not entirely true. Sure, Uranus does have a tilted axis of rotation, but it still manages to spin in the same direction as most other planets in our solar system. It's like that one friend who always shows up late to the party, but still manages to have a good time and fit in with the crowd. But let's be real, Uranus is still a bit of an oddball. It's the only planet in our solar system that rotates on its side to such a degree. But after all, variety is the spice of life, right? So cheers to Uranus, the planet that refuses to conform to anyone's expectations. Ugh, I wish I had the guts to be like this. Have you ever heard someone say that Neptune is just a blue version of Jupiter or Saturn? Well, let me tell you, that's like saying a banana is just a yellow version of a cucumber. It's not even close. Sure, Neptune and its gas giant buddies share some similarities, but Neptune stands out in the crowd with its beautiful blue hue. It's all thanks to the methane chilling in its atmosphere. By the way, did you know that it's the farthest planet from the Sun? It's so far out there that it takes almost 165 Earth years for it to complete one orbit around the Sun. Talk about taking your sweet time. And let's not forget about its 14 moons. That's right, Neptune has a whole entourage of moons following it around like groupies at a concert. Maybe they're hoping to catch a glimpse of Neptune's famous blue glow. So next time someone tries to tell you that Neptune is just a knockoff version of Jupiter or Saturn, you can confidently correct them and say, "Excuse me, but Neptune is its own unique gas giant with a fancy blue vibe." Did you know that Pluto isn't actually considered a planet anymore? That's right, in 2006, the International Astronomical Union decided to reclassify Pluto as a dwarf planet. So what exactly does that mean? Well, a dwarf planet is a celestial body that orbits the Sun and is big enough to be rounded by its own gravity. But it hasn't cleared its orbit of other debris. It's a common misconception that Pluto is still considered a planet, but the truth is that it's just not big enough to make the cut. Sorry, Pluto. Don't worry though, you may be small, but you're still loved by many. Plus, being a dwarf planet is pretty cool too. You get to hang out with other celestial misfits like Ceres and Haumea. So keep on orbiting, Pluto. We still think you're out of this world.
This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, It's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. Ooh. This discovery challenges what we thought about how planets survive near aging stars. It raises two theories. One suggests that Baekdu was once two stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the two stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 100-07b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 100-07b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 100-07b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 100-07b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals. which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth, and its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. This would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that, a fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1. Insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2. Heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3. Underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4. Salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5. Building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and -200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars. Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates.
In 2021, astronomers announced that they had found between 70 and 170 free-floating planets. Such planets are also called rogue because they don't orbit around any star. And the majority of these huge unattached planets, each approximately as large as Jupiter, dwells in one particular region of the Milky Way galaxy. It's known as the Upper Scorpius OB Stellar Association. Wow, doesn't it sound like the name of some homeowners association? Anyway, this conclusion was made by a team of astronomers that used telescope observations from all over the world and in space. They also looked through 80,000 wide-field images taken over a couple of decades. Scientists have estimated there might be billions or even trillions of rogue planets wandering around our galaxy. If their estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Ooh. This region of the sky is around 420 light-years away from Earth. A lot of amateur astronomers are familiar with it since lots of cool stuff is located there. The most famous targets for astrophotographers include dark nebula, like Barnard 68, Coal Sack, or Pipe Nebula, as well as the colorful region around Rho Ophiuchi. But let's get back to mysterious rogue planets. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. Recently, astronomers have announced one more finding, the tiniest known rogue planet. The mass of this space traveler is somewhere between the masses of Earth and Mars. The term itself, a rogue planet, suggests that such celestial bodies might desert their stars on purpose. They wander off on their own, carving a new path through the Milky Way. But the reality is much more tragic. Rogue planets are usually kicked out of their star systems, doomed to a solitary existence of circling the center of the galaxy on their own. How sad. You see, things get messy when planetary systems, including ours, form. While planets appear from the cosmic dust surrounding a newborn star, they jostle one another around. This gravitational game of pool can easily shove some planets toward the edges of a star system, or eject one or two of them altogether. Then there are also nearby stars that can shove planets around too. Most stars are not born on their own. Clusters of dozens to thousands of stars often appear in space. No wonder that in such a crowded environment, a star with its own set of planets might whisk away a planet or two from another star. After stealing a planet, it can keep it for itself or cast it out into space. At the same time, some free-floating planets might form in a different way, with no parent star to help them. They appear from collapsed clouds of gas and dust, just like stars do. But sadly, they don't manage to put on enough weight to start nuclear reactions, the ones that make stars emit light. These objects are also known as failed stars. Hey, who said they failed? And they resemble planets. Rogue planets are very hard to detect. When astronomers want to find an exoplanet, they look for something blocking the light of its parent star. That's usually the planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because, in this case, there's no parent star. The only way to locate them is to rely on gravity. Now, imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the star's light. This, in turn, makes the star appear brighter than usual. As for the duration of this brightening, it depends on the nature of this moving object. If the brightening lasts a few days, it's a star. If the duration is about a day or so, it's a Jupiter mass object. And if it's just a couple of hours, this object is something that equals the mass of our planet. But the trickiest part is to figure out whether this object is indeed a rogue planet. It's true that stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there still might be a parent star, invisible because of the glare of the luminous star. And astronomers have to wait up to a decade for the luminous star to move a bit to check for a potential parent star. If there's still no parent star in sight, then it's proven. The planet is traveling solo. One thing is clear. Without parent stars to warm them, rogue planets are frozen worlds. Even if ice doesn't go all the way down to their cores, it certainly covers such planets with hard, icy shells. On the bright side, maybe free-floating planets aren't as lonely as we think. They might have moons of their own. They probably take them along when they get pushed out of their cosmic homes. Even more exciting, these exomoons might have liquid water. At least that's what a 2021 study published in the International Journal for Astrobiology claims. Actually, I don't get that magazine, but it sounds fancy. But could a free-roaming world find a new home near a different star? Some experts think it's unlikely. The universe is an incredibly spacious place, and even a large star is hardly able to slow down enough to lasso a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or slowing down. But what if it was a rogue planet? Would it stay with us? Astronomers say it's unlikely. If it happened, they would be thrilled, such a research opportunity. But the rest of us would likely be terrified by the implications of having such a neighbor. At the same time, maybe it wouldn't be such a big problem, considering how big and very empty our solar system is. But even without a rogue planet invading our solar system, the orbits of our planets are going to change one day. In 5 billion years or so, the Sun will start to dim. It'll begin to lose its mass until its gravity is too weak to hold on to the outermost planets of the solar system. Neptune, Uranus, and probably Pluto might turn into rogue planets. They will slowly drift away, unbothered by the cold and mostly unchanged due to their already frozen environments. And yeah, I know the scientists demoted Pluto as a planet years ago, but it's still a planet to me, so sue me. And what about Earth? Oh, our planet will have a different fate, much more tragic. As stars lose mass nearing the end of their lives, they eject gas and dust in all directions. And since our planet is in the way, it'll most likely get enveloped in this scorching stream and vaporize. But calm down, it won't happen for a few more billion years. And who knows where humanity will be at that time. As for now, astronomers hunt rogue planets with enthusiasm. For example, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey to discover more free-floating exoplanets using its powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept, cleverly called Cleopatra. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. To maximize this effect, Cleopatra might hitch a ride on a Mars-bound mission. It's supposed to place it in orbit around the Sun. That's a sufficient distance from Earth, which can help the mission effectively measure the parallax signal and fill in the missing information for astronomers. Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean Eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater, a vast basin on the Martian surface where, billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and is capable of heating Martian rock samples to extreme temperatures. There are two ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced two possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet. And it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. that would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor, and this could help us avoid similar mistakes in the future. Okay, it seems scientists have come across a strange object in space, and they're not sure if it's a star or a planet. What we do know is that it's located 1,400 light-years away from us, and it makes us question what we thought we knew about the universe. Let me explain the dilemma here. We can tell if something is a star or a planet by considering the object's mass or the amount of stuff it has. Stars have a lot of mass, which gives them strong gravity that squeezes them tightly. Squeezing creates high temperatures inside them, causing them to shine brightly. Planets have less mass, so their gravity is weaker. They don't experience the same squeezing or high temperatures as stars. Instead, planets shine because they reflect the light from their stars, like our beautiful Earth does with our Sun, too. And this weirdo falls somewhere in between, since we consider it a brown dwarf. It's a special type of big, gaseous protostars. Brown dwarfs are usually like Jupiter in terms of their atmosphere, but they are much larger in size, about 13 to 80 times. If a brown dwarf has more than 80 times the mass of Jupiter, it can start burning regular hydrogen, just like a star. That's what usually makes stars shine brightly. But normally, brown dwarfs are not as hot as stars. Their inability to burn hydrogen has even earned them the nickname of failed stars. They burn at around 4,000 degrees Fahrenheit, which is cooler than most stars. But this object defies the norm. Its temperature measures an incredible 13,900 degrees Fahrenheit. Now let's put that into perspective. The hottest day in history was reported to happen in Death Valley, California, more than 100 years ago, with a temperature of 134 degrees Fahrenheit. People back then must have felt like they were melting along with everything around them. Now imagine getting closer to the Sun, like taking a trip to Venus. Venus can reach insane temperatures of 860 degrees. It's not only about the distance, though. Mercury is the planet closest to the Sun, but it's still colder than Venus. Venus is extremely hot due to the greenhouse effect. Did you know that Venus could have been a delightful place to live a long time ago? Or at least be home to any form of life. But at some point, it started to trap carbon dioxide and eventually created this thick, smoggy oven that doesn't release heat. And that's why it's so hard to explore. The longest a probe managed to last on Venus was 2 hours. But hey, that's longer than I can do at work, and then I melt. So yeah, then you get to the Sun. Its surface burns at an incredible 9,930 degrees Fahrenheit. And what's fascinating is that this weird brown star we're talking about is hotter than that. I mean, it's not hotter than the Sun's core, whose temperatures go up to 27 million degrees, but it's still very impressive and unusual for a brown dwarf to be this hot. At least that's what everyone thought until they realized why it was happening. The brown dwarf is remarkably close to another star that falls into the category of white dwarfs. They're so close to each other that our mysterious star makes one orbit around its white dwarf friend in just 2.3 hours. Woo! How old we'd be over there! Since they're this close, they're tidally locked like our Moon and Earth. That means one side of this brown dwarf always faces the white dwarf, and the other side is forever in darkness. Because of all this, our brown dwarf is superheated on one side only. So its day side is what got us confused. While the temperature on the night side is what you would expect from a brown dwarf. But these extreme conditions won't last long. Such a hot temperature makes the molecules in the dwarf's atmosphere break apart into individual atoms. And while its molecules are falling apart, this brown dwarf is slowly disappearing. And if you think this brown dwarf is hot, what would you say about Eta Carinae? It's a star located about 7,500 light-years away from Earth, and it belongs to an elite group of stars we call luminous blue variables. One astronomer first noticed it in the 17th century, but back then it was just a regular medium-bright star. Almost 200 years later, another astronomer was observing it, but this time it was a very bright star, one of the brightest ones in the sky. A few years later, it reached the highest level of brightness in a big event called the Great Eruption. When it happened, the star could be easily seen in the night sky. It released so much light, as much as is emitted in a supernova explosion. It remained like that for a couple of years, which is not what usually happens with exploding stars. After the party reached its peak, the star decided it was time to leave. It's still hesitating though, so it's still alive but dimmer than before. There's a nebula around Eta Carinae too. It is a shell made of gas and dust that formed during the Great Eruption. It even blocks some of the star's light. Eta Carinae is a binary star system. That means there are two stars that orbit around each other. One component has a temperature of about 26,500 degrees and the other 62,500 degrees. The main star in the Eta Carinae system, which is the more massive of the two, is 100 times heavier than our Sun. Because of its enormous mass, scientists predict that this star may eventually explode in a powerful event known as a supernova. But not for another several thousand years. So, by now, you might have already guessed what the hottest thing in the universe is. Ta-da! A supernova. The supernova is what tells us that the life of a star has ended. We're talking about the most powerful explosions in space. They happen when a star that's between 8 and 40 times more massive than our Sun flops. Its core can no longer create enough energy through a process called fusion, so the star can't even handle its own gravity. It's like a stellar burnout, too much work a star can't handle, and its core just collapses. During a supernova, the temperatures in the star's core can get 6,000 times higher than in the core of the Sun. Or sometimes, a specific type of star called a white dwarf suddenly restarts its nuclear fusion, and bam, you get a supernova again. Kepler's supernova happened at the beginning of the 17th century, and it was the last really big supernova event we directly observed from Earth. On average, supernovas in our galaxy happen 3 times every century. I mean, we got a smaller supernova in 1987 too, when a blue supergiant exploded in one of the Milky Way's satellite galaxies, which we know as the Large Magellanic Cloud. This explosion was so strong, people could even observe it with the unaided eye, even though it was incredibly far, 168,000 light-years away from our home planet. What a topic for summer days, huh? But check this out. We can also talk about the hottest thing people have ever created, made in a surprising place, Switzerland. Nah, we're not talking about a super hot chocolate. A group of scientists there created a subatomic soup called a quark-gluon plasma. In this experiment, the temperature got 250,000 times as hot as the Sun's core. The purpose of this experiment was to recreate the conditions that existed shortly after the Big Bang, when the universe was still in a state of chaos. Okay, let's get even more extreme. In theory, things can get even hotter. Have you heard of the Planck temperature? It's an insanely hot temperature with numbers so high we can't even imagine. A supernova is like tepid tea compared to this madness. And who even knows what the matter does at these temperatures? Okay, I'm done. Now we take you back to your regular universe. Bye now. It seems like NASA and China are each planning to send humans to Mars. Both space agencies have tentative plans to launch the first crewed missions by 2033, right when Mars and Earth are playing a game of tag. And that's not all. Other missions may happen in 2035, 2037, and beyond. The ultimate goal is to build a Mars habitat for future exploration and research. So, how are they going to do that? Well, let's find out. Now, traveling to Mars isn't as easy as hopping on a rocket. The distance between our planets can change a lot over time, ranging from around 35 million miles to 250 million miles. And even with our best technology, it takes 6 to 9 months just to get to the red planet. So, a round trip to Mars could mean spending 3 years away from Earth, dealing with extra radiation and floating around in microgravity. But NASA's Jet Propulsion Laboratory has some exciting news. Scientists have been working tirelessly to design a minimal architecture mission to Mars. They're thinking that 2033 is the perfect year to make it happen. So here's the deal. Every 15 years, the rocky planets, Venus, Mars, and Earth, align just right to create a cosmic sweet spot. The mission will make the most of this rare alignment and perform an epic gravity assist maneuver using Venus. It's like getting a boost from a planetary slingshot. We'll speed up our spacecraft and reduce the need for making our own propulsion. The report also talked about some really cool ideas, like using nuclear power for spacecraft engines and using Martian resources to make things. These technologies could make space travel faster, protect astronauts from radiation, and make it easier to live in space. They might even let us make resources and fuel right on Mars. So this is how the plan goes down. First, we'll launch a spacecraft towards Mars. It'll spend around 30 days in high orbit, exploring and gathering valuable data. Then it's going to head back to Earth, also swinging by Venus for a quick visit. So this whole adventure will last approximately 570 days, which is just 1.6 years. And a shorter adventure means less exposure to radiation. Now keep in mind, this mission will focus on orbiting Mars rather than landing on its surface. It's just a stepping stone, paving the way for future landing missions. Just like Apollo 8 mission orbited the Moon before Apollo 11's historic landing. Landing on Mars by 2033 might be a bit too ambitious due to funding constraints, but who knows? If all goes smoothly, it could become a reality. Now for the coolest part. We don't need fancy new technologies or vehicles for all this. We'll make use of existing ones that are already in production or being studied for the Artemis moon program. Now let's break down our Mars mission vehicle, a big puzzle of many parts. And guess what? It was put together by a community of space enthusiasts back in 2017. That's right, it wasn't the scientists who produced it first. But now, this isn't just some fantastic idea anymore. Most of these things are already becoming a reality, being made or planned by NASA. So let's take a look at this concept. First, we have the Orion spacecraft. This is the spaceship that will take the crew to the orbit around Earth and bring them safely back home. It's like a super fancy space taxi, and it might be the most powerful taxi to ever exist. It's combined with 3 powerful propulsion stages, and we're also using a special fuel that doesn't need to be ultra cold like in the movies. Next, there's the Earth departure stage. This is an important part of the mission. It helps us make a powerful thrust that sends us on our way to Mars. Then we have Mars transit habitat. This is where the crew will live and hang out during their journey to Mars. Like a cozy space house with all the things they need to be comfortable. And finally, the Mars orbit insertion stage. When we reach Mars, this awesome thing will help us slow down and enter its orbit smoothly. It's our maneuvering expert. Even the Mars transit habitat is being developed and might even be tested in a few years. That means we're on track to have the whole thing ready for our amazing Mars mission by 2033. In other words, it's all about working with what we've got and making it happen. Now, let's talk about the plan's timeline. Mid-2028, the action begins. First, we'll need to do a couple of test flights. We'll send 2 stages ahead of time to make sure we can come back to Earth safely. These stages will join together like 2 spaceships becoming best buddies. They'll orbit the red planet and then come home. To do all that, we'll use powerful rockets and 13 commercial launches. It's going to be a huge space party. Late 2032. After all that, we launched the fully assembled Mars mission vehicle to high Earth orbit. So far, this is an empty vehicle that awaits astronauts. If all is good, then it'll be ready for the final check. March 2033. Time for our brave crew and their Orion spacecraft to join the party. We launch them and they dock with the Mars mission vehicle in Earth's orbit. They'll make sure the whole lot is just right before we head to Mars. Flexibility is important, so we can adjust our plans if needed. April 2033. Everyone's ready for the adventure. We perform a powerful burn, like a big push that sends us on our way to Mars. The crew will travel for about 200 days. November 2033. Finally, the crew reaches the red planet. Once they're in Mars orbit, they'll spend about 30 days exploring and doing awesome space stuff. Mars will be our playground. When it's time to return home, they'll say goodbye to the stage that helped them get into Mars orbit. Then their vehicle will meet up with the 2 stages we sent ahead. Remember these space buddies? And after that, it will take us about 340 days for the crew to come back to Earth. This is where we'll use the gravity of Venus to slingshot around the Sun. To keep the equipment and crew at the right temperature, we'll have a sunshade that will protect us from the Sun's heat since we'll be really close to it. In the end, Orion will re-enter Earth's atmosphere and splash down in the water. What a heroic ending! And this would be just the beginning. Our awesome team has another plan for the bravest adventurers out there. It's called the Conjunction-class long-stay mission. It launches in April 2033 and lasts a long time, 950 days. That's more than 2.5 years, with 550 days spent in Mars orbit. It requires fewer launches from Earth, but has some different challenges, like spending more time in microgravity and dealing with increased radiation. So we'll need some real space heroes for this one. But of course, there are some major hurdles to overcome before we can make all this happen. Experts closely looked at NASA's Journey to Mars program and found that the plan needs some serious changes. There are a few high-risk areas, like life support systems for long missions, using solar power for propulsion, making oxygen on Mars, and so on. They're also worried about timelines, funding, and many other things. So, according to them, sticking to a deadline of 2033 might be impossible with the current plans and budgets. Even aiming for 2035 carries significant risks and possible delays. But hey, space exploration has never been easy, right? With realistic determination, anything is possible. Most likely, the idea of sending people to Mars will be realized before 2040. NASA is working on finishing the plan and details to make this possible. So, even though we still have some tough nuts to crack before we can make it a reality, the dream of sending humans to Mars is exciting. It's a thrilling adventure full of challenges, discoveries, and the spirit of human exploration. So, let's show the universe what we're made of. And that would be mostly carbon. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out, there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star, while the other side remains in perpetual darkness. So, one side is always very hot, while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and 2 planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its 2 giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape. Kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets.
And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
We just can't get enough of Mars, can we? Everyone wants to go there, and astronauts are now looking at caves on the red planet where they can live once people inhabit it. The planet itself has some similar characteristics to Earth. Yeah, it's somewhat smaller than Earth, but the time it takes for the planets to revolve around themselves is also similar, which is about a day. On paper, Mars might seem like a good idea given some similarities to Earth, but there are some factors we need to pay attention to before we consider stepping foot there. The temperature. Mars might look like a scorching hot planet like a freakishly large Sahara Desert, but quite the opposite. It's really cold. Mars has a reputation for being a freezing, desolate, endless land that happens to have the largest mountain in our solar system thus far. So, within those mountains, astronauts and scientists are considering whether naturally built caves are the answer to our survival. Caves won't be the worst thing we'd live in, considering our ancestors used to dwell in caves in communities. Logically, it's the best place to stay dry during a storm and keep warm. It's the best place for protection against predators like giant birds, elephants, and saber-toothed cats. We even had our first art shows in caves with evidence of cave art dated thousands of years ago. Caves are a good idea, and they can also help us save a lot of money when establishing a colony on Mars. Rather than building a fresh structure in the middle of an open plain, the cave structure will help and influence the architecture, potentially saving lots and lots of money. Going to Mars will be expensive. It's already expensive sending people to the moon and launching a rocket into space. So, we have to consider the logistics. Another thing to look out for is caves in the ground that are not necessarily stuck on mountains. Scientists believe that most potential places for humans to thrive are caves. These spaces are large enough to host large populations. So far, they identified 9 caves as large as football fields. So what would life look like if we lived in caves on Mars? For one thing, sunlight would be hard to access. By the time we reach Mars, we would have the best technology to maximize our lifespan in a hostile environment, which means withstanding the harsh sun rays of Mars. Most likely, we would dig through the caves further underground where oxygen would be pumped for everyone to breathe. People can walk around casually, thinking they're on Earth, and to exit the caves, you would need to wear a special suit. These cave colonies would have dormitories for people to live in and special spaces for colony meetings, entertainment, grocery markets, schools, and other places that are needed to sustain a colony. There would also be indoor farms to grow crops and raise livestock. A team of experts mapped out what some of the dwellings will look like on Mars. And just like on Earth, we will have apartments for young professionals, family homes, and luxury mansions. Some of the dwelling units would be placed on the surface and not in caves. One of the key elements of the design and architecture is how to build it around the natural light to brighten up the homes. Another element is how to deflect radiation and cosmic rays. because Mars has such a thin atmosphere, sun rays and other hazardous objects easily enter Mars. The dwelling units also have to be sturdy to protect them from severe dust storms and extreme cold temperatures. Some of the living pods or dwelling units that are for couples or singles would have tunnels leading to a shared workspace and garden. Studies show that even being in the presence of greenery can reduce stress levels significantly, and on the red planet, we would definitely need some greenery. We can expect the family homes to be built within the caves, not necessarily underground. It would be tempting to head outside with the view of Mars, but the large thick glass would prevent anything from coming in and out. Those who are underground with a view rely on LEDs and camera systems to screen the surface landscape of Mars so it acts like real windows. And if you're bored of the surface, you can always switch the channel and watch something else as you please. Maybe a flowing river surrounded by trees, or maybe a penthouse view of all of New York. The choice is yours. There would be a driveway that leads to a garage so one can enter and exit easily. There won't really be a reason to exit the cave colony except probably to visit other cave colonies. In this case, we would have highly crafted vehicles that will take people from colony to colony on the surface. The vehicles can withstand harsh temperatures and would be constantly transporting people daily. Some people might live in a certain colony and have to commute to work every day in other colonies. Humans might not have to be working in dangerous conditions or on the surface. We would have robots that will do that for us. The thing about robots is that they don't need to be human-shaped to do a job. However, before transporting humans to space, we would need to create some human-like robots and land them on Mars. With the exact physical form, we can determine what would happen to people if they were on Mars. We would have robots for specific tasks, helping us with everything. Let's not forget artificial intelligence plays a major role in monitoring the systems and updating the functionalities of the colony. It'll know when certain systems need fixing, adjusting, renewing, and changing. We also need people to keep an eye out for anything out of the ordinary, and also to make sure people are behaving and not breaking the law. Getting to Mars would be the earliest obstacle we will face. We've already launched some robots to explore the terrain and conduct some studies. At first, we would send robots to test the conditions and to build most of the infrastructure. To build a proper colony, we would have to send out young couples willing to dedicate their lives to the future and the future of their children. It won't be easy. In fact, there would be a variety of people with different professions and specializations to help establish the colony. People would have to work and establish a local economy. We would need scientists, doctors, farmers, teachers for the children, and engineers to maintain the structure. It will take time for the colony to reach a substantial size, but it's all part of the process. Even the spaceships would need to be large and sufficient to house thousands of people traveling from Earth. Of course, by then, most of the dwelling units would have been built, and people would have already picked out their houses, depending on if they were single or if they were about to start a family. Once the colony has the necessary professionals it needs, then come the other people who wish to start their life on Mars. People would need entertainment, so musicians would find a place in the colony. We can't expect everyone to go out on a nice sunny day to the beach, but perhaps one day, when the colony is large enough, there can be an artificial body of water with the same elements as the beach. Livestock animals would also be shipped from Earth to be raised on Mars, where they can populate for our nourishment. We can also bring most of the animals and establish a wildlife sanctuary for everyone to enjoy and for the animals to thrive. For now, humans are planning on reaching the Red Planet sooner than we think, and who knows, maybe you can be one of the first people to sign up and have your own little dwelling unit far away from Earth.
Imagine if somewhere, trillions of light years away from our world, there's another version of you watching this very video right now. Not as crazy as it might sound. The multiverse theory is having its time of the day, from Marvel's movies to Spider-Verses to the recent famous hit Everything Everywhere All at Once. But it's not just some wild sci-fi concept. Physicists have been talking about this theory for decades. Let's see what they say. Do parallel worlds exist? If they do, let's hope that this is the reality where you click that subscribe button before diving into the video. Now, everything starts with the Big Bang. Before the Big Bang, the universe, with everything we know, was crammed into an unbelievably tiny, super hot, and mega-dense point. Our universe is about to burst into existence. And then, boom! The most colossal event you can imagine happens. In an instant, this tiny point expands with indescribable speed. It's the beginning of everything – time, space, and all the galaxies that surround us. Then, like an extremely hot balloon, the universe started stretching out in all directions, which sounds logical, but what's curious is that this inflationary epoch lasted for an incredibly brief time, in less than a blink of an eye. It's like the universe hit the fast-forward button, and then everything eventually slowing down over time. After this speedy phase, the universe kept growing, but at a more normal pace. This rapid expansion is called inflationary cosmology. It explains some big mysteries about our world. It tells us why it looks the same in all directions, why the background radiation is evenly spread, why galaxies are where they are, and so on. The details of how this cosmic inflation works are still a bit mysterious, but scientists are on it, and the theory itself is universally accepted. But it wasn't always this way. To scientists, this idea sounded like insane sci-fi at first. However, it explains so many things that the scientists just had no choice but pay attention to it. However, its initial weirdness was just the beginning. Now, according to this theory, inflation might not be a one-time thing. It could be happening repeatedly, maybe even endlessly. Picture the universe as a never-ending cycle, with each burst of inflation creating its own bubble universe. And the most important thing is that these bubble universes might not play by the same rules. Some could be totally weird, where the laws of physics are going crazy in ways we can't even fathom. Which means there might be a whole constellation of bubble universes out there. However, we can't directly see these other bubbles. They exist beyond the edge of our spotlight. That's where the multiverse theory comes into play. People have been chatting about the idea of multiple universes for a long time, like way back in ancient Greece. Now, back in the 1990s, people got really interested in this idea, and this concept started popping up in books and movies. As a result, scientists began talking about it increasingly in scientific discussions and journal articles. And nowadays, many scientists and philosophers are into it. Now, the problem is, there's no solid proof or evidence that these other universes really exist. It's not a proved or confirmed theory. It's not even a theory at all, just a hypothesis, a bunch of interesting thoughts put together. Before we draw any conclusions, we need much more in the way of clues and evidence, and unfortunately, it's hard to find the evidence of parallel worlds when we can't live or look past our own, which is why many scientists believe that it might not be real. But not everybody agrees with that. While critics say that we can't observe the multiverse, and therefore can't test it, some physicists suggest a different approach. Instead of trying to find these parallel worlds, we could try to look at ours and its history. Around the 2010s, researchers took a closer look at data from a space gadget called the Wilkinson Microwave Anisotropy Probe. Yes, that's a mouthful. They thought they found signs suggesting that our universe might have bumped into other universes in the past, like sort of a collision. But then scientists used an even fancier satellite, which had 3 times better resolution, looked at the data more thoroughly, and didn't find any strong proof of these universe collisions. Plus, there was no evidence that other universes were tugging on ours with their gravity. However, an interesting discovery happened in 2015. One scientist checked out radiation left over from the Big Bang. He claimed to see something super bright, 4,500 times brighter than expected. Well, at least based on the stuff, like protons and electrons, scientists think existed in the early universe. So he and some others assumed that this might be our first evidence of our universe crashing into others. But let's assume that it does exist. The multiverse wouldn't be about human decisions creating alternate timelines. In quantum mechanics, it's not human decisions that split everything into parallel worlds, but the measurement of subatomic particles. So if we look at this theory scientifically, other worlds would be billions of light years away, and what's happening to them wouldn't have anything to do with our daily choices. So what would it look like? Well, Max Tegmark, for example, talks about 4 levels of universes and multiverses. Level 1 is the extension of our world. Our universe is a big place, and in an infinite universe, there would be infinite chunks like ours, each with its own story. Most of these chunks might look different from ours, but because there are so many, some might look just like ours, but they'd be really, really far away. Level 2 is a universe with different physical constants. This idea says that our universe is part of a much bigger space where bubbles form. Each bubble might have its own set of rules, like different laws of physics. Level 3 is the many worlds interpretation of quantum mechanics. This one's a bit tricky. In the quantum world, things can be weird. Imagine rolling a dice. Each number that comes up might create a separate universe. So if you rolled a dice and got a 3, in another universe, it would be a 6, and so on. Yeah, my head's spinning. This idea suggests that every possible outcome in quantum events creates a whole new universe. And level 4 is the ultimate ensemble. This level gets super abstract. It says that everything, every possible universe or reality, can be described using math. I wish now I hadn't fallen asleep in algebra. Imagine all the different math equations describing every conceivable way the universe could be. This level says that every math equation that can describe a universe actually exists, and they're all real in their own way. Stephen Hawking was a proponent of the Level 3 many worlds interpretation. It was one of his last theories before he passed away. He predicted that the universe is finite and far simpler than many current theories about the Big Bang say. According to Hawking, the universe is like a giant quantum system, a sea of possibilities and probabilities. In this view, every outcome of the universe's history plays out in parallel existences, and we, as observers, play a crucial role. Our existence and what we observe, according to Hawking, actively shapes the universe we see. In simple words, the universe is a canvas and we're all painters. Sounds very cool and insane, but hey, many things in science were considered crazy before they turned out to be true. So, is there another copy of you somewhere watching this video and who just pressed the like button? Who knows? If there are infinite copies of us, scientists assume that we might be like identical twins, sharing the same origins and starting from one thing, but then developing into separate different people. And if these worlds exist, perhaps we can even visit them one day. There could be some connections between us, something that could allow for interdimensional travel. For example, wormholes. Well, whatever the truth may be, let's hope that one day we'll discover it. Until then, stay curious.
You must have heard that humans were supposed to fly to Mars within the next 10 to 20 years, but now the mission seems to be at risk. A new study has revealed the dramatic effects that such a journey can have on the human body, and because of that, the entire planet is now at risk. Samples from over 40 missions, which involve both mice and humans, have shown that the conditions in space are likely to have an even more negative influence on our bodies than we thought. Both NASA and SpaceX are planning to send crewed missions to Mars in the coming decades, but new findings might put an end to these projects. Researchers at University College London have discovered that microgravity and galactic radiation in space cause serious health risks, and they become more and more pressing the longer someone is exposed to these conditions. Surprisingly, the body part at the highest risk is the kidneys. The research has shown that after less than a month in space, some parts of the kidneys show visible signs of shrinking. So before we go all the way to Mars, we'll need to develop measures to protect the kidneys and other parts of the body. This will allow astronauts who will take part of this mission to avoid irreversible damage to their health, which in turn means that future missions to Mars haven't been completely ruled out yet. The author of the study, Dr. Keith Sue, mentioned that they already knew about the issues that astronauts had after short space missions, like kidney stones for example, but they still don't know why such problems occur or what is going to happen to astronauts on much longer space flights, such as the planned mission to Mars. If they don't manage to develop new methods to protect the kidneys, astronauts who will eventually reach the red planet might need serious kidney treatment already on their way back. Unfortunately, the effects of radiation damage on kidneys appear pretty late. By the time they become apparent, it might be too late to prevent a kidney failure. This can be catastrophic, not only for the astronauts, but also for the entire mission's chances of success. Meanwhile, an astronaut on Mars is likely to receive up to 700 more daily radiation doses than those we get on our home planet. The Earth's magnetic field and atmosphere protect people from the non-stop bombardment of cosmic rays. These energetic particles travel close to the speed of light and can easily penetrate the human body. In space, astronauts aren't protected against this radiation as effectively as on Earth, which can increase the risk of many serious health issues during long missions. Damage to the human body can extend to the brain, heart, eyes, and central nervous system. Physicists studying cosmic radiation explain that one day in space is equivalent to the amount of radiation one receives on Earth for a whole year. Moreover, most of the changes in the genes of the astronauts are likely to be the result of radiation exposure. That's what a recent NASA's twin study claims. It has shown DNA damage in astronaut Scott Kelly compared to his identical twin and fellow astronaut Mark Kelly, who remained on our planet. Another source of space radiation are the unpredictable solar particle events. They deliver high doses of radiation in short periods of time, which can lead to radiation sickness if astronauts don't take special protective measures. Even space flights orbiting close to the Earth, including the International Space Station, have highly adverse health effects. These days, research communities are focused on musculoskeletal, neurological, ocular, and cardiovascular degeneration, and these issues can appear as soon as a few weeks into a mission. At the same time, the effects of low Earth orbit flights are less clear when we talk about other organs. More research is definitely needed.
In 2025, humans will have a unique opportunity: travel to the moon. So far, only 12 people have walked on Earth's natural satellite, but a private company is offering tourists a chance to change that. If you are hog stinky rich, you can pay $750 million to spend several days exploring the moon and watching Earth from a distance. You can even join unique scientific experiments. Now, humans also want to build their forever homes on the moon. In fact, NASA believes that North Americans may have their own share of the moon by 2040. And you don't even need to be an astronaut to buy a plot of land on the moon. Of course, billionaires are already making plans. Their first idea is to exploit natural resources. The moon is packed with stuff that is rare here on Earth, like helium-3 and many rare Earth minerals, or more precisely, rare moon minerals. But I digress. Hey, if you can get your hands on some of it, you may get even richer. First, helium-3. It's great for clean nuclear energy, but it's super rare on Earth because it escapes into space. The moon, though, has tons of it, enough to power Earth for 1,000 years. Rare earth minerals are not actually rare on Earth, but they're hard to mine because they react with oxygen. On the moon, hey, there's no oxygen, so we could easily get loads of these materials to make better tech, like electronics and batteries. Scientists aren't thrilled about this. For the first time, they have a chance to explore 4.5 billion years of space history, because the moon's soil has stayed the same for billions of years. Studying its rocks could reveal lots of secrets about the universe's origins. But if billionaires mine the moon and destroy these rocks, all that knowledge could be lost forever. Another problem with exploring the moon is the size of it. The moon is big, but the best spots, the ones with water and sunlight, are limited. Most of the lunar surface is dangerous because of earthquakes or moonquakes, radiation, and meteorites. That means tourists, scientists, and mining companies would be elbowing each other in 3 small regions. The first region is called the Peaks of Eternal Light because there's always sunlight over there, making it a great energy source for telescopes or human colonies. The second spot is the far side of the moon. Here, radio signals from Earth are not so strong. It's not just peaceful and quiet there. It's also a great place to set up a telescope and study the universe. The third place is called the Pits of Eternal Darkness. It's where all the trolls on social media go on vacation. Nah, it's really because no sunlight reaches that area. This place is even better for scientists because they can use special astronomy tools to study the most distant parts of the universe. This is also where you can find about 1 billion tons of water. If scientists could visit the moon and study it, they would make amazing discoveries. But today, there are no international laws protecting space. No country can own the moon, but this can't stop a private mining company from calling dibs on a particularly good spot. In the past, a bunch of nations signed the Outer Space Treaty, and they agreed that space exploration was supposed to benefit all humankind. But exploring it is not cheap in the first place. Taking a single gallon of water from the moon to the Earth is extraordinarily expensive, and I bet not everyone can afford that. Human activity on the moon is also extremely dangerous because it might change its atmosphere. Now, to understand it better, let's look at the surface of the moon. This floating rock has many craters that have been forming for billions of years. When a meteorite crashes into the moon, fine dust called regolith, with particles so tiny they can cut like glass, rises into the air. This process once created the atmosphere of the moon, and this atmosphere is quite different from the atmosphere of Earth. A big rocket landing on the moon can launch this fine dust into the lunar sky, and the difference here is that the space objects crashing into the lunar surface are actually gentler. A rocket landing is so intense it can increase the number of atoms in the sky 100,000 times. If the number of atoms in the atmosphere grows, the air turns into a dusty plasma. This means that you'll be breathing in air as toxic as the one that poisoned miners in the olden days. Such an atmosphere could end space tourism too, because it makes electronics malfunction and machinery shut down. Well, truth be told, our own presence on the moon is already dangerous. When scientists discovered water on the surface of the moon, they were super excited to study it. This was their chance to understand where this water came from, and even figure out how water appeared on Earth. But when our spacecraft land on the moon, outgassing occurs. This means that the water on the surface evaporates. This evaporated water can contaminate the water on the moon, ruining all scientific data. Because when astronauts take a sample of the lunar water to study it, they will get the water from Earth they have brought along. Bummer, really. And it's not just the water we contaminate, it's everything. A spaceship can carry any living thing from Earth to the moon. It can also bring extraterrestrial life forms back to Earth. This type of contamination is extremely dangerous because it can put human lives at risk. Something similar happened when Europeans were exploring unfamiliar lands they came upon in the Americas. They accidentally introduced new microbes to the natives they met. And since the immune systems of the native population were not used to those new bacteria and viruses, they got sick and worse. At the same time, Europeans also became ill with diseases their bodies didn't know about yet. And even though moon tourism is not happening yet, humans are already littering the lunar highlands like their own backyard. In 2024, an artist named Jeff Koons sent a sculpture to the moon. The sculpture is a transparent box filled with spheres, and it got to the moon thanks to a ride on a SpaceX Falcon 9 rocket. In each sphere, Koons engraved the name of a human he considered super important to humankind, like Aristotle, David Bowie, and Leonardo da Vinci. Thankfully, you don't have to go all the way to the moon to see this sculpture. You can purchase an NFT of each sphere. Or not. Back in 1971, the crew members of Apollo 15 also left a couple of things on the moon. A figure created by a Belgian artist and a commemorative plaque to honor other astronauts who couldn't be there. And it's not just art that humans dumped on the moon. If you take a walk, you might just stumble upon 413,000 pounds of materials left behind, including a gold olive branch, a falcon feather, a silver astronaut pin, a Bible, some golf balls, a hammer, and even leftover urine collection kits. Most of this stuff was left behind by the astronauts that explored space between the 60s and 70s. So you can find moon rangers, lunar probes, and orbiters that are decades old already. Now, to be fair, bringing back unnecessary equipment costs a ton of money. And back in the 60s, their priority was the safety of the astronauts. The sad truth is that the moon is already turning into an extraterrestrial landfill, and we don't even live there yet. But now we want to settle there, so NASA is trying to get rid of all this trash. The good news? Hey, you can be part of this process. The space agency launched a competition called the Luna Recycle Challenge, and if you want to join it, you must find ways to reduce the amount of litter produced and recycle it into materials that can be used for space exploration. To win, you need to develop a way to completely recycle the trash that is on the surface of the moon. You will help science and win $3 million. And if you get this sum, well, you might finally afford a ticket into space. Our universe is like a giant highway, and galaxies are constantly moving along this highway. And just like cars driven by careless drivers, they can collide and crash. So, astronomers have recently witnessed such an incredible cosmic collision. It involved galaxies traveling at incredible speeds. Using advanced instruments, researchers clocked one galaxy traveling at a speed of around 2 million miles per hour as it crashed into a group of other galaxies. This collision has created shock waves that are so powerful they can completely reshape the entire region, leaving long-lasting effects on its structure and dynamics. Will it somehow influence our solar system? Before we find out, let's learn more about the region where this collision occurred. Actually, this collision is still happening in Stephan's Quintet. That's a fascinating cluster of galaxies that has been the subject of study for scientists for over a century. It's a group of 5 galaxies located in the constellation Pegasus. This group of galaxies was first discovered in 1877 by the French astronomer Édouard Stephan, who used a telescope at the Marseille Observatory. Despite its tranquil name, Stephan's Quintet is anything but peaceful. It's a chaotic spot filled with galactic collisions and turbulence. 4 out of the 5 galaxies are gravitationally bound. It means they are physically interacting with one another. Such interactions are ejecting material from the galaxies, and over time, it forms vast debris fields in the space surrounding the galaxies. Astronomers believe that, in the end, these galaxies will merge into one giant galaxy, but it will only happen in millions of years. The curious thing, though, is that the 5th galaxy in the quintet, located in the upper left corner of images, is not part of the collision. This galaxy is much closer to Earth, more than 200 million light-years closer, to be precise. So its alignment with the other galaxies is just a chance perspective from our vantage point, making it appear as part of the group. Stephan couldn't know this in the 19th century, so the name Quintet has remained, even though only 4 galaxies are physically involved in the collision. Now, how about we look at this collision in detail? At the center of this event is one of the galaxies in the group, which is currently crashing into the others at a breathtaking speed. From our perspective on Earth, this galaxy appears to be approaching the quintet from behind, heading directly toward the viewer. The collision is creating a massive shock wave that ripples through the surrounding galaxies. As the shock wave is moving through packets of cold gas, it's traveling at hypersonic speeds, several times the speed of sound in the intergalactic medium. This process strips electrons from atoms, leaving behind long trails of glowing ionized gas. But when the shock wave comes across regions of hot gas, it compresses the material rather than disrupting it. This compression produces radio waves, which can be detected by radio telescopes. While reshaping the structure of the intergalactic medium in Stephan's Quintet, this shockwave also influences the future evolution of the galaxies involved. Now, how did scientists even manage to spot such a dramatic space event? All thanks to innovative technologies. The most important participant was WEAVE, a cutting-edge spectrograph that's installed on the William Herschel telescope in La Palma, Spain. This tool specializes in gathering spectroscopic data, which is the information about how matter absorbs or sends out light and radiation. It allows astronomers to examine the movement and composition of space objects with great precision. Besides WEAVE, researchers have used data received from a few other large observatories. One of those was LOFAR, Low Frequency Array. It's a radio telescope with an antenna network observing the radio waves the weaker shock wave produced while compressing hot gas. Astronomers combined the data received from all these instruments and managed to study the shock waves and their effects in amazing detail. This collision in Stephan's quintet gives us a fantastic opportunity to find out more about the interactions between galaxies, which can influence the evolution of the universe. You see, when galaxies crash into each other, their gas and dust gets redistributed, and it can trigger the formation of new stars and even cause central supermassive black holes to grow. And if we talk about Stephan's quintet, the ongoing collision in this area helps us get additional information about the behavior of gas under extreme conditions. Now, at the same time, galactic collisions aren't as rare as you might think. They're common on a cosmic scale, and in the early universe, collisions occurred even more frequently because galaxies were located much closer together. With time, such interactions have played a key role in shaping the universe. Even our own galaxy, the Milky Way, has experienced tons of past collisions. We can see the evidence of such destructive interactions in the form of debris streams and disrupted star clusters within the galaxy. In fact, astronomers predict that the Milky Way will collide with the neighboring Andromeda galaxy in about 4.5 billion years, eventually forming a new, larger galaxy. Even though they're moving at incredible speeds, galactic collisions are super slow processes from our human point of view. While galaxies may travel at millions of miles per hour, the distances they cover are so vast that mergers take millions to billions of years to complete. Now, galactic collisions don't look like explosive crashes you might be imagining. Instead, they resemble when fluid merges. When two galaxies collide, their gravitational forces distort their shapes. They stretch and warp, and exchange their material, stars, gas, and dust. As a result, tidal tails, rings, and even bridges between galaxies form. One of the most famous collisions between galaxies is ARP 148. During this cosmic crash, one galaxy became shaped like a ring, while the other stretched in a long tail-like form. That's how powerful gravitational interactions between galaxies during collisions are. But however impressive intergalactic collisions are, collisions between neutron stars, those ultra-dense remnants of massive stars, are among the most energetic phenomena in the universe. Neutron stars are incredibly small and dense. Just one contains the mass of our Sun packed into an area the size of a city. When two neutron stars collide, they often merge to form a black hole, releasing immense amounts of energy in the process. These events produce gravitational waves, ripples in space-time, that can be detected by instruments like LIGO and Virgo, as well as bursts of light that outshine billions of stars. On Earth, the possibility of a galactic collision directly affecting us is extremely low. Luckily, the timescales and distances involved make such events harmless to life on our planet. However, smaller-scale collisions, such as an asteroid impact, are more plausible. Asteroid impacts have occurred in Earth's history, and the most infamous of them caused the extinction of the dinosaurs 66 million years ago. And while large impacts are rare, astronomers closely monitor near-Earth objects to protect our planet from potential threats. Now, while we're talking about space collisions, a question may arise. Can life travel between planets? This is the idea of lithopanspermia, the transfer of life between planets via debris from collisions. If an asteroid or comet hits a planet, fragments of rock could be ejected into space. If those fragments carry microbial life, they might land on another planet and seed life there. And guess what? According to experiments, certain super tough microorganisms like cyanobacteria could survive the harsh conditions of space travel, including radiation and re-entry into the atmosphere of another planet. In any case, lithopanspermia is still only a theory and a controversial one among scientists, but it doesn't make it less fascinating. It might eventually help us understand how life could have spread across the universe. But let's return to the ongoing collision in Stephan's quintet. By studying such events, astronomers learn more about how galaxies interact, evolve, and influence their surroundings. Hopefully soon, we'll find even more interesting facts about this process. Stay tuned.
So the idea of panspermia is that life can travel through space naturally, like seeds being spread around the universe. It's been debated for ages, but we didn't have any proof until recently. Now, with new discoveries and research, we're taking it seriously. People used to think it was impossible for living things to survive being launched off one planet, traveling through space, and land on another planet. But turns out microorganisms can handle it. Scientists got interested in this again in the 70s when they found rocks from Mars here on Earth that proved it's possible for rocks to travel between planets in our solar system. They figured out some ways that materials can be sent into space and survive the trip. So yeah, panspermia might be a real thing after all. Basically, scientists were wondering if living things could have hitched a ride between planets in our solar system. But for that to happen, microorganisms would need to survive being launched off of one planet, flying through space, and then landing on another planet. So, scientists have done a bunch of experiments trying to simulate all those crazy conditions. They found that spores can survive each stress individually, and even combined stresses can be simulated in the lab. For instance, microbes could totally survive the trip from Mars to Earth or any other habitable planet in our solar system. And get this, it's not just Mars and Earth that could be swapping germs. There are all these cool moons around Jupiter and Saturn that might be habitable too, like Io, Europa, Ganymede, Callisto, Titan, and Enceladus. Plus, microbes can survive in space for years with just a little UV protection, like they could be space superheroes with a dash of sunscreen. And if they're shielded by 6.5 feet of meteorite, they could live for 25 million years up there. That's longer than most marriages last. But wait, it gets crazier. Scientists found microbes on Earth that were brought back to life after 250 million years. That's like finding a fossil and then it jumps up and says, "Surprise!" All these discoveries have changed the game when it comes to finding life on other planets. We used to think life could only exist on cushy Earth-like planets. But now we know that extreme environments are fair game. And with our improved knowledge of these environments, we've been able to develop astrobiology, which is all about studying the origin, evolution, and distribution of life in the universe. Mars is one of the most promising places to look for life. We've found evidence that it used to have an environment similar to Earth, which means life could have flourished there. And get this, scientists found trace amounts of methane in the Martian atmosphere that could be produced by living organisms. Plus, they recently discovered subsurface liquid water lakes on Mars. So, maybe there are some Martian microbes chilling down there. Europa is another exciting prospect. It has a subsurface ocean that could support life similar to Earth's deep ocean hydrothermal vents or the Antarctic lake Vostok. And Enceladus has hydrothermal vents on its subsea floor and high-speed jets of water vapor and organic-rich particles gushing out from its southern region. So who knows what kind of alien creatures are lurking out there? Bottom line, space is wild and full of surprises. Who knows what kind of crazy stuff we'll find next? Yeah, that long explanation was all about panspermia. But that's definitely not the only theory about the origins of life in space. There's just panspermia theory, but there's also directed panspermia. This theory is a bit crazy though. It suggests that life on Earth was deliberately seeded by an advanced extraterrestrial civilization. This idea is based on the assumption that life is rare in the universe and that it's unlikely to have originated on its own on Earth. Directed panspermia is basically the idea that dudes from other planets intentionally sent life to Earth. I'm not kidding you. Some people think that extraterrestrial beings might have purposely sent microorganisms or even whole organisms to our planet to kickstart life here. The idea is that those dudes might have wanted to spread life throughout the universe, and Earth was just one of their stops. It's kind of like intergalactic gardening. They planted the seeds of life and let it grow. Now, this theory might sound a little out there, but some scientists actually take it seriously. They argue that it's possible that life on Earth is too complex to have just randomly formed on its own, and that an outside force had to have played a role. I personally prefer classic panspermia theory over this one. There's another theory called chemical evolution, and it suggests that life on Earth originated from simple organic molecules that formed spontaneously in the early Earth's atmosphere or in space. These molecules then combined and evolved into more complex structures, eventually leading to the formation of living organisms. The conditions on early Earth were different from what we see today. The atmosphere was mostly composed of gases like methane, ammonia, and carbon dioxide, and there was no oxygen. These conditions were conducive to the formation of organic molecules. One of the most famous experiments that supported the chemical evolution theory was the Miller-Urey experiment in 1952. In this experiment, Stanley Miller and Harold Urey simulated the early Earth's atmosphere in a laboratory and produced amino acids, which are the building blocks of proteins. This experiment demonstrated that organic molecules could be formed from simple inorganic compounds under conditions similar to those found on early Earth. Over time, these simple organic molecules combined and evolved into more complex structures, eventually leading to the formation of living organisms. This process is believed to have taken millions of years and involved many intermediate steps. While chemical evolution is still a theory, and there are still many questions to be answered about the origins of life, it provides a plausible explanation for how life could have arisen from non-living matter. Hey, ready for the next theory? Meet hydrothermal vent theory. This one suggests that life on Earth originated near hydrothermal vents on the ocean floor. These vents provide a unique environment where chemicals and minerals mix with hot water, creating conditions that could have supported the formation of organic molecules and the evolution of life. This theory is another idea about how life could have started on Earth. Basically, it suggests that deep under the ocean, there are these hot vents where water, heated by the Earth's core, comes out. These vents are full of minerals and chemicals that could have provided the perfect conditions for life to begin. Scientists think that the first living organisms could have started around these vents, using chemicals and minerals to create energy. Over time, these organisms evolved and spread out into other parts of the ocean. The hydrothermal vent theory is still being studied and debated, but it's an exciting idea that could help us understand how life began on our planet. The last, but not the least, RNA world hypothesis. This theory suggests that RNA, aka ribonucleic acid, was the first self-replicating molecule that led to the evolution of life on Earth. RNA is capable of both storing genetic information and catalyzing chemical reactions, making it a possible precursor to DNA and proteins. Basically, the name of this hypothesis is a fancy way of saying that life on Earth might have started with a molecule called RNA. RNA is like a cousin to DNA, which is what makes up our genes. Scientists think that RNA might have been the first molecule that could make copies of itself, which is a key part of how life works. The idea is that in the early days of Earth, there were all these chemicals and stuff floating around, and somehow these chemicals combined to make RNA. Then, because RNA could make copies of itself, it started to spread and evolve into more complex forms of life. It's still just a theory, but it's a pretty cool one. And who knows, maybe we'll find out one day that it's how we all got here.
Imagine something terrible happening to Earth and humans having to leave it as fast as possible. And you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now, without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants, and plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produce small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, Solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments. Millions of people around the world go out on the streets and rooftops to look at the amazing cosmic phenomenon. Another planet right next to the moon, a big red one. At first, everyone's excited. Mars showing up out of nowhere is having a strange effect on humanity. Just as the moon can affect the psychological and physical state of some people, Mars's unexpected visit is causing people to behave pretty strangely. Every night, the sky is lit up by the white light of the moon and the red glow of Mars. Many people get a sort of instant insomnia. Some even stop drinking coffee because they no longer feel sleepy. Mars brings out energy and a little wildness in people, making them laugh more, and even drives a few poor people crazy. They begin to go out of their houses more often and enjoy the unusual night sky. A few days later, everybody can see what's happening. Mars is getting bigger. Scientists announced that the red planet is slowly moving towards Earth. A collision is inevitable. Earthlings only have a few years left. A few months ago, a huge asteroid crashed into the red planet with such force that Mars simply flew out of its own orbit and went rogue. The chance that Mars would fly close to Earth was always going to be pretty high. After about 3 seconds of being announced, the news went viral, and panic set in. The situation's getting worse and worse. The closer Mars gets, the more it affects people on a physical level. Hundreds of videos pop up showing collision simulations of Mars and Earth. And there's no happy ending. Want to see what happens? One famous blogger asked her followers. The Earth's almost completely covered with water, and Mars is all dust, sand, and rocks. Then she puts a huge watermelon in the middle of her room. From the far end, she launches a bowling ball at it. Strike! Mars looks almost the same size as the Moon now. It's about to come into the Moon's orbit, and it's affecting the Earth's magnetic field. Floods, hurricanes, tsunamis, powerful thunderstorms. They go from bad to worse. Animals go crazy. Birds no longer migrate south. The polar northern lights appear in the Caribbean. The economy isn't handling the news that well. People stop showing up to work. Why wouldn't they? They just want to have fun and be with loved ones. There are enough resources on the planet to last until the catastrophe, so no one's even trying to fix the Earth's problems. Clothing, food, cars, yachts, whatever, everything loses its value and becomes free. Every day, huge street parties pop up all over the world. People decide to live their last months in peace and harmony. The global catastrophe is uniting humanity like never before. To go out with a bang, Earthlings team up to organize a huge rock concert. The red giant destroying our beautiful blue planet. Yeah, rock and roll's the perfect soundtrack. There's just enough time to eat, dance, party, and listen to good music. Huge stages are built all over the planet. It's every musician's last concert. During all that preparation, hope suddenly appears. Scientists have calculated all the events that'll occur when Mars crashes into Earth, and they have a simple plan. Luckily, humans had already planned on moving to Mars, so they already have been building spaceships for years. There's no time to get to another planet before the collision, but the good news is that people can wait out the disaster just outside Earth's orbit. You get to sit in a space station, munch some popcorn, relax, and enjoy the show. When the dust settles, it might just be possible to return to Earth, or what's left of it. After learning about this plan, people start working on finishing the ships night and day. Everyone in the world pitches in. There are still 2 years left before the big day. The huge concert stages are converted into more space stations. Mars is now giving people more energy, and with epic teamwork, people manage to create thousands of stations in just a few months. That's what happens when 7 billion people work together. Farmers, physical therapists, chefs, engineers, athletes, accountants, all on the same team. Mars is now closer to us than the Moon. The red giant blocks out the sun, and our planet is plunged into darkness. There are only a few days left. People are working like ants in a massive colony, putting the finishing touches on several 100,000 space stations. It takes 4 whole days for everyone to get on board. Plus, there's the loading of supplies, animals, fish, seeds, plants, vegetables, fruits, video games, fruit roll-ups. The red giant is scheduled to enter Earth's orbit in a couple of days. That's when it will really pick up speed. Mars is only a little more than half the size of Earth, but up in the sky, it looks infinitely huge. The ships start taking off. People take a last look around, memorizing every inch. In a few hours, it'll all change forever. The stations fly up far enough away to clear any orbits. 2 worlds colliding together should still have a soundtrack, though. Rock stars on every ship organize an outer space music festival. To the awesome sound of rock, Mars enters Earth's atmosphere and burns a thin layer of its own surface. This releases an incredible amount of energy. It gets faster and faster and smashes into the Pacific Ocean. A huge blast wave sweeps across the entire planet. Everything is lit up by flames, and everyone on the ships has to put on sunglasses to avoid being blinded. Our blue planet is turning into a fiery one. The dust of Mars mixes with the water of Earth. The force of the impact goes through the Earth's crust into the liquid hot magma. Hundreds of pieces of Mars, some the size of entire countries, are somehow floating in the atmosphere. The collision generates so much energy that all oceans boil and evaporate. Seas and rivers of molten metal are now spreading all over Earth. Days, weeks, months pass. A belt made up of bits of Mars forms around the Earth. It's like a fiery version of Saturn. It'll take a long time before it's safe to land back down, but humanity can't stay alive on the ships all that time. Food, water, and oxygen will run out after a few years. But scientists already have a plan. The ships flip a switch and become huge cryo chambers. The ships are equipped with energy panels, and the roasting hot Earth's giving off a lot of energy. Totally enough to keep the ships working while everyone on board takes a few thousand-year nap. As soon as the planet cools down, humans will wake up. Hundreds of thousands of years pass. One day, alarms go off simultaneously on all the ships. People wake up, slowly. Their bodies are exhausted, but after a few billion cups of coffee, everyone's ready to go. Down on Earth, new continents should have formed, and the atmosphere is most likely way different. The planet might have lost its original orbit, so it might be spinning at a different angle. The seasons as we know them, gone. All the water on Earth evaporated in the first few hours. But there were huge glaciers on Mars, which might have melted on impact. Mars may have shared its water with our planet. The clouds of dust and dirt should have settled by now, and the ground should be pretty good for growing stuff on. All that magma probably spewed up a bunch of useful minerals and chemicals. It's going to be difficult, but humanity somehow must adapt to the new Earth. People are ready for anything. All the Earthlings run to the nearest windows to see what their beloved planet looks like after all these centuries. Where is it? People are craning their necks, looking out at the empty spot where the Earth used to be. The impact of Mars was so strong that it pushed the Earth out of its orbit around the Sun. It's gone. Great. What are we gonna do now? Some bearded guy grabs a guitar and says, "Let's